In this explainer, we're going to cover how to build front ends using Streamlit. We're going to break down the kinds of interactive applications you can build, what the development process actually looks like, and then we'll dive into the essential API commands that you'll be using constantly. So let's start with the most important question. What can you actually build with Streamlit? Let's look at a few concrete examples where it really excels. The number one use case, of course, is dashboards and reporting. Think about your classic KPI overviews, where users need to be able to filter data or drill down into the details. Streamlit makes it super easy to display time series data, interactive tables, and even add a button for users to download the data as a CSV or Excel file. It also supports periodic updates, which is perfect for any kind of live monitoring. But it goes way beyond just viewing data. Streamlit is fantastic for building internal tools. You know that common upload, validate, transform, export workflow? You can wrap that whole process in a simple web app. It's also great for creating QA interfaces for reviewing datasets or building a UI to configure and kick off more complex jobs. And you can take that even further. You can build some pretty sophisticated data explorers that let non-technical users run database queries through a simple interface, complete with faceted filters and sorting. And your apps don't have to be just a single page. Streamlit supports multi-page applications, so you can build out entire mini-sites with proper navigation. If you add a bit of your own logic, you can even implement things like user logins and role-based access control. And for something a little more modern, Streamlit has become a go-to for prototyping chat interfaces and AI assistants. You can quickly implement a chat window that remembers the conversation history and integrate run buttons to trigger AI tools. But, and this is a really important point, you have to know its limitations. If you need a pixel-perfect, highly customized website, you're still going to reach for a traditional front-end framework. Streamlit is about speed and functionality, not custom design. So how do you actually get started? Well, the development workflow is one of Streamlit's most powerful features. It is designed to be incredibly fast and simple. It really is just 4 simple steps. First, you pip install it. Second, you create a Python file, let's say app.py, and you start writing your code. Third, you pop open your terminal and run streamlit run app.py. And fourth, this is where the magic happens. You just start iterating. Every time you save your code, the app in your browser automatically reloads with the changes. This hot reload feature makes the whole development process incredibly fluid. All right, now for the core of it all, the API. Let's walk through the essential commands that are basically the building blocks for any Streamlit app you're going to create. The first thing in almost any script is st.setPageConfig. This lets you set the browser tab title, the little icon, and the overall page layout, like making it wide. Then you have your standard text elements, like st.title and st.header for structure. For organizing your app, st.columns and st.tabs are absolutely essential for keeping things clean. And if you want to put any element into the sidebar for global controls, you just prefix it with st.sidebar. Now, to make your app interactive, Streamlit gives you a whole suite of input controls. You've got your basic st button, of course, but also things like st.textInput and st.slider for numbers. You can use a select box for single-choice dropdowns or a multi-select for choosing multiple items. And you've also got standard checkboxes and radio buttons. One of the most powerful ones for data apps is st.fileuploader, which makes handling file uploads a total breeze. Okay, this is an absolutely crucial tip for performance and just for good user experience. By default, every time a user interacts with a widget, drags a slider, clicks a checkbox, the entire script reruns. For a complex app, that's a disaster. It feels slow and clunky. To solve this, you group your input widgets inside an ST form. This changes everything. Now the user can tweak all the settings they want, and the app only reruns once they click the form's single submit button. So once you have some data, you need to show it. State.DataFrame gives you a really nice interactive table right out of the box that the user can sort and search. For those KPI dashboards we talked about, State.metric is perfect for displaying a key value and its change. When it comes to charts, you can use the simple built-in ones for speed, or you can integrate powerful libraries like Plotly for complete control. And of course, showing images, videos, and adding a download button are all just single lines of code. Providing feedback to the user is also super simple. You can show success or error messages in these clean, colored boxes to confirm an action or highlight a problem. For any long-running process, you should use st.progress or st.spinner to let the user know that the app is working and hasn't frozen. And for a quick little notification that just pops up and then fades away, st.toast is perfect. Now, once you've got those basics down, there are a few advanced concepts that are pretty much essential for building more robust, high-performance apps. The most important concept to grasp is state management. Remember how the script reruns on every interaction? Well, you need a way to remember information between those reruns. That is exactly what st.sessionState is for. It's basically a dictionary where you can store anything you want to persist across reruns, like a user's login status, their selected filters, or what step they're on in a multi-step process. For performance, caching is absolutely non-negotiable. You use the @stream.cacheData decorator on any function that fetches data. Think of a slow database query or a call to an external API. Streamlit is smart about it. It caches the return value. If that function gets called again with the exact same inputs, Streamlit just serves up the cached results instantly instead of running the expensive operation all over again. Now, it's really important to distinguish cache data from cache resource. Think of it this way. Cache data is like taking a snapshot of the result of a calculation. Cache resource, on the other hand, is like keeping the calculator itself in memory. You use this decorator for the heavy objects you only want to load once per session, like a database connection pool or a big machine learning model. This prevents them from being reinitialized on every single script run. Okay, let's wrap this up by tying everything together with some common design patterns and a quick look at how you get your app out into the world. You'll start to see a few battle-tested patterns in most well-built Streamlit apps. The classic layout is to put all your filters and navigation in the sidebar, which leaves the main area of the page clean for displaying the results. We already hammered on using forms for performance. For logic, session state is your go-to for any kind of multi-step wizard. And just for good coding practice, it's always a good idea to wrap distinct UI components into their own Python functions to keep your main script readable. When you're ready to deploy, you really have two main paths. For quickly sharing public prototypes and demos, the Streamlit Community Cloud is amazing. You just connect it to your GitHub repo and it's live. But for serious, professional, internal-facing apps, the standard approach is to package it in a Docker container. You can then deploy that container on any cloud platform like AWS or Azure, usually placing it behind a corporate reverse proxy that handles single sign-on. So, the real takeaway here is that Streamlit massively lowers the barrier to creating interactive data tools. And that leaves us with a really fascinating question to think about. If any Python script can now be turned into a web app with just a handful of new lines, what entirely new categories of tools will data teams start building for themselves next?